In this podcast, we're going to look at the concept of the distance, the slope, and the midpoint uh, as regards 2 points in a plane. That is, what is the distance between the 2 points in the plane, what is the slope of the line connecting the 2 points in the plane, and how would we find the coordinates of the midpoint of the segment connecting the 2 points. We'll start with the distance. Suppose I'm given 2 points in the plane as in the drawing here. -4, -2, that's 4 to the left, 2 down, and 6, 4, 6 to the right, 2 up, 4 up from the origin. We'll call this first point down here x1, y1, just meaning the first xy, and the second point x2, y2, meaning the second point xy. And we want to know how far is it from this point to this point. To figure that out, we can go back to an old friend from high school here, the Pythagorean theorem. The Pythagorean theorem says if you have a right triangle with legs A and B and hypotenuse C, then you can find the relationship between those distances by the formula c squared equals a squared plus b squared. This square on the hypotenuse is the sum of the squares of the other two sides. We can use that same rule here to solve for the distance between them. If I call that distance d, I can get a right triangle just like the one above by simply bringing out a horizontal from the first point. So I bring out a horizontal here and bringing a vertical down from the second point. And then this lower becomes side A and this one becomes side B, just like in the drawing above, and we call the hypotenuse length D. Now let's see how we get this length A. This point is 4 to the left, that's the -4. This point is 6 to the right, that's the +6. So the total length here is 10, and I could get that 10 by doing 6 minus -4, which is the same as x2 minus x1. On the length B, I can do the same thing. The length here is 6 because this point is 4 up. This point is 2 down, so that's a total length of 6, and I could get that 6 by doing B is equal to y2 minus y1, which would be 6 minus -2, 4 minus -2, which would give me my 6. Now, given that those are the lengths of the side, that side A is x2 minus x1 and side B is y2 minus y1, then using the Pythagorean theorem, I can write that d squared, now make sure you use squareds here, is a squared, which is x2 minus x1 squared, plus b squared, which is y2 minus y1 squared. So that if I want to get d, I'll just take square roots. And I get d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, which is the same in our Pythagorean theorem as a squared plus b squared. Notice that's a plus in the middle, just like in the Pythagorean theorem. A squared plus b squared. Now to actually formulate that or to calculate that, you need to be a little bit careful, especially if one of your points has negatives, like point 1 here. So a good habit is to write it with empty holes the way you always do when you substitute. So I'd have an open, and then for x2 I'd put an empty hole, minus x1 I'd put an empty hole and a closed squared. And then the same open for a y2 an empty hole, for a y1 an empty hole, and then close squared, and then very, very carefully plug in. The first numbers are x2, and this should have been an x here, excuse me. The first numbers are x2 and x1, so x2 I can read up here as 6, and x1 I read down here as -4. The next numbers are y2 and y1. y2 I can read up here as 4. y2 I read down here as -2. And so I get the square root, well 6 minus -4 is 10, so 10 squared is 100 plus, and 4 minus -2 is 6, so that's 36. So I end up with the square root of 136. Now that will break down. 136 is the same as 4 times the square root of 34. That is 4 times 4 is 16, 4 times 30 is 120, add them up, you get 136. And of course the square root of 4 is 2, so this is 2 square roots of 34 in its simplified form. Now that's the Pythagorean theorem. Recall this is just d is equal to the square root of a squared plus b squared. That's x2 minus x1 squared plus y2 minus y1 squared. These quantities, x1 minus x2 and x2 minus x1 and y2 minus y1, come into play in the slope formula. Recall the formula for slope, which means the rise over the run, is given by y2 minus y1 over x2 minus x1, and you can kind of see that in the drawing. If you come over here to the one where we're looking for slope and we complete the same triangle that we completed above, then this vertical part is called the rise, and we found that by y2 minus y1, and this horizontal part is what we call the run, which we found from x2 minus x1. And so what we're going to basically do is put the rise over the run. That's where the y2 minus y1 over x2 minus x1, the exact same expressions we used in the distance formula, come into play in the slope. So again, y2 is 4, y1 is, we've got these backwards here, they're supposed to be negative 4, negative 2. y1 is negative 2, x2 is 6, x1 is negative 4, so I end up with 4 minus negative 2 are 6, over 6 minus negative 4 are 10, and usually we put that in a reduced form. You always want to reduce it if you can. So we would say the slope over there, the rise over the run, is 3/5. Finally, we want to take a look at, okay, given those same 2 points in the line, what point would be in the exact middle of the line segment connecting them? Well, it looks like it'd be about right here, doesn't it? And if you bring off a horizontal to this line, notice that the halfway point of this line is also the halfway point of the rise. It looks like its rise is about the same above and below, and if you drop a vertical down, the midpoint of this slanted line is the same as the midpoint of the run. Well, how do you find that midpoint of the rise? Well, you just average the two y numbers. And for the midpoint of the x's, you would just average the two x numbers. So we could say that the midpoint, which I'll call MP, is just given by the ordered pair. I'm looking for the coordinates of the point in the middle, the midpoint, and that ordered pair would be x average, y average. Now these formulas are also somewhat related to the ones above, but instead of y2 minus y1, if I wanted to average my y's, I'd add them up and divide by 2. So that would be y2 plus y1 over 2. And similarly, if I was averaging my x's, I'd add up my two x's and divide by 2. So in the first two formulas, we were using expressions like x2 minus x1. Here you could call it x2 plus x1 because you're averaging, you're adding them up and dividing by 2. So if I want the midpoint of this line, my x average would be the average of my two x's. Negative 4 plus 6, that's x1 plus x2 over 2 to get the average. And then for my average of the y's, they were negative 2 and 4, so negative 2 plus 4 over 2. So each of those is 2 over 2, which is 1. So I end up with a 0.11. And if you look at the middle, it looks like it's 1, 1, doesn't it? It looks like if you average the x's and average the y's, you get the midpoint. Try to think of it that way. Learn this as your formula, and if you're thinking of the average, you'll know you have to add them up and divide by 2 and not subtract as you do with the distance and the slope. And that completes our podcast on distance, slope, and midpoint.